Assalamu alaikum. This is chemistry 11th, and our today's topic is this. It is Whisper theory, and that is a valence shell electron pair repulsion theory. Now, before going through this theory, I would like to give you a recap of this covalent bond. Dear students, as you know that a covalent bond is formed between two similar atoms or between two atoms of of similar electronegativities by sharing of electrons, and depending upon the number of shared electron pairs, if there is sharing of one pair of electrons, we get a single covalent bond, and if there is sharing of two pairs of electrons, then we get it a double covalent bond, and if there is sharing of three pairs of electrons, then we get a triple bond. Now, to account for the shape of the molecules, or to account for the geometry of the molecules, this whisper theory, it was put forth by Gillespie and Nihom in 1957 to predict the shapes of these molecules, covalent bonded molecules. A covalent bonded molecule, according to this theory, this states that in a covalent bonded molecule, the central atom, it bears two types of electrons, that is the electrons which are involved in chemical bonding. They are called as the bond pairs, and the electrons which do not participate in chemical bonding, or which are not involved in bonding, they are called as the lone pairs. Now as far as these electrons are concerned, being negatively charged and similar charged, there occurs a repulsion. And now there occurs a repulsion between these electrons, and this repulsion, it is minimum in case of bond pairs, that is, the repulsion is minimum between bond pair and bond pairs, and it is maximum in case of lone pair repulsion, and it is intermediate between lone pair and bond pair. That means we can say the repulsion between the electron pairs, that is bond pairs and bond pairs, it is least, and then it is in case of lone pair it is maximum. The repulsion between lone pair is maximum, and it is in between, that is intermediate between lone pair and bond pair. Now these electrons, these electron pairs, that means bond pairs, whether these are bond pairs or they may be these lone pairs, they get themselves arranged in such a way so that there is a minimum repulsion as possible. Now the geometry of the molecule depends upon the geometry, or we can say the shape of the molecule, it depends upon the number of bonding pairs and lone pairs of electrons. Now, as far as the postulates of this whisper theory are concerned, or valence shell electron pair repulsion theory, they are concerned. Number one, the shape of a molecule depends upon the number of electron pairs. That means the geometry of the molecule, it depends upon the number of bond pairs and lone pairs. Now, if the central atom in a molecule bears only bond pairs, then it will have a regular geometry, or it will have a regular shape, and a particular shape that will depend upon the number of bond pairs. For example, if I have got only bond pairs, say if I have got only two bond pairs, for example, two bond pairs, the molecule will have a linear geometry, and the bond angle will be 180 degree. Now the examples are this: we have got beryllium fluoride, we have got mercury chloride, etc. These are the examples of these linear molecules, and having two bond pairs. Now we have got the molecules in which we have got three bond pairs. The molecule will have equilateral trigonal this geometry, and the bond angle will be 120 degree. and the examples of this trigonal geometry, it will be, we have got boron trifluoride, we have got boron triiodide, etc. So these are the examples of the molecules which have got which bear only bond pairs, and that too only 3 bond pairs. Now as far as the molecules which have got 4 bond pairs, bond pairs, the molecule will have a tetrahedral geometry, and the bond angle will be 109 degree and 28 minutes. And the example we have got, this is methane, we have got this is SnCl4, etc. Now, in case of molecules which bear 5 bond pairs, the molecule will have a trigonal bipyramidal geometry, or it will have a trigonal bipyramidal shape, and we have got the angle, the bond angle in case of this triangular portion, we will have bond angle of 120 degree, and the 2 bonds which lie above and below the plane of this triangle, they will have a bond angle of 90 degree. Now the examples we have got in case of this trigonal bipyramidal, we have got this phosphorus, we have got pentachloride, we have got antimony pentafluoride. So these are the examples which these are the molecules which have got a trigonal bipyramidal geometry, as they have got only 5, we have got only 5 bond pairs over here. Now as far as the molecules which have got 6 bond pairs, bond pairs, the molecule will have an octahedral geometry, and the bond angle will be 90 degree. And the examples we have got, this is sulfur hexafluoride, we got SiF6 anion here. Now in this case we have got, there are only 6 bond pairs, so the molecule will have a regular geometry, or it will have a regular octahedral shape. Now as far as the molecules which have got 7 bond pairs, the molecule will have a pentagonal bipyramidal this geometry, and the bond angle of this pentagon, it would be 72 degree, and the 2 bonds which lying above and below the below this plane of this pentagon, they will have the 90 degree angle. Now the example of this is, we have got interhalogen compound, we have got IF, this is IF7, this is iodine, this is heptafluoride. Now this is when the molecule, when the central atom in a molecule has got only bond pairs, and there would be no repulsion, so the molecule can have a regular geometry. Now these electron pairs around the central atom, they tend to repel, as they tend to repel one another, thus they tend to occupy such positions in space, so that they are at maximum distance apart to minimize the repulsive force. Because once these electron pairs are much apart from each other, the repulsive forces would be minimum, or they would get minimized. This is second postulate. Now the third postulate of this Vsepr theory is that if the central atom in a molecule bears lone pairs in addition to the bond pairs, since if there are only bond pairs, then the molecule will have got a normal or regular geometry. Now in addition to these bond pairs, if the molecule has got a lone pairs, the shape of the molecule will not be regular then, but it will get distorted. And why it will get distorted? It is because of the repulsion between these electron pairs. As we know that the repulsion between lone pair and lone pair, it is maximum, and it is least in case of bond pair and bond pair. Now thus, as a result of due to the presence of these lone pairs of electrons on this in the central atom in a molecule, the bond angle will get altered, and obviously the molecule will have a distorted shape or distorted geometry. Now the extent of distortion in case of these irregular molecules, it varies, and it depends upon the number of lone pairs. That means greater the number of these lone pairs in the central atom, greater will be the extent of distortion. For example, in case of this methane, you can see over here we have got only bond pairs. The molecule will have a regular tetrahedral geometry, and the bond angle will be and the bond angle will be, it is 109 degree and 28 minutes. Now if we take the example of this ammonia, it has got a pyramidal shape, and it has got a distorted tetrahedral shape, since there is sp and this sp3 hybridization. So in this case we see the actual bond angle should have been 109 degree and 28 minutes like that, 28 minutes like that of this methane, but the actual bond angle that has been found, it is 107 degree and 3 minutes. The reason is that we have got a lone pair of electrons over this nitrogen atom, and it exerts a repulsive this force over the three bond pairs, that is NH, NH, NH. So as a result of which the bond angle gets altered, rather it gets decreased from 109 to 107 degree and 3 minutes. Now in case of water, we see again water, since there is sp3 hybridization, the bond angle should have been like that of this methane, that is 109 degree and 28 minutes, but actually the bond angle is 104 degree and 5 minutes. Again in this case we see that we have got two lone pairs over the oxygen atom, so the extent of distortion is greater as compared to that of ammonia. Now because of this greater extent of this distortion, the bond angle gets it gets lowered from 109 degree to 100 from 109 degree 28 minutes to 104 degree and 5 minutes. So in this case the extent of this distortion is greater, so it will have a distorted this tetrahedral geometry, while as in case of this ammonia, the extent of distortion is less as compared to that of water, because we have got only one lone pair over nitrogen atom in ammonia. So the bond angle is 3 degree and 107 degree and 3 minutes. Now in this case we see this has got a regular tetrahedral shape. So these are the various these postulates of this Vsepr theory. Then we'll separately then take up this ammonia and this water and methane in our next lecture. This for today. Thank you very much.